Hey guys. So, oftentimes the regents will expect you to decide what kind of numbers will be reasonable to use in a given context. This is really something you need to think through logically. So, let's look at these three examples. What kind of numbers would you use if you were discussing the number of pets each student has? It seems almost too easy to be true, but that's literally what my question is right now. So someone could have 0 pets. They could have 1 pet, 2 pets. I mean, depending on their life, I guess they could have like 97 pets. But we're just going to keep counting up by ones. You can't really have half a pet. Even if the pet's missing some limbs or anything, you know what? That's still a full pet. No half pets. All right. The second one here. The cost for a pumpkin weighing a certain amount. Well, whenever I'm thinking about cost, we're talking money. So the pumpkin could be $3.31. It could be like this crazy giant pumpkin. It could be like $72.43. I don't know, just any monetary amount. This would be a really fancy pumpkin though. It's recording this on Sunday morning right now. I'm a little bit tired, little exhausted. So hopefully this little guy helps brighten the video for you wonderful folks. All right. The last one, we're talking about a contestant's score on Jeopardy. Optimistically, you want to end up with a score like 10,300. In reality, sometimes it doesn't go so hot for people. They get questions wrong. They do not get a lot of questions right, and they end up in the negative. So someone could have a score like -600. You don't want that. It's really sad, but it happens. Oh, look how sad. Okay. So as long as you can figure out just what kind of numbers we're working with, you'll be able to answer these questions on the regents. They do end up as multiple choice. We're going to see some more today, but it's just kind of about thinking through things logically. So the domain of a function, this is something you're going to be seeing a lot of, so you're going to need to be familiar with this terminology. The domain of a function is the set of all the inputs. So domain is just talking about the x values for which we're going to get an output. So that's just what numbers would be reasonable to plug in. If I had like f of x equals y, the domain is this part. So this guy right here, whatever we're plugging in for x is our domain. All right. And if the domain refers to my x values, well, the range is going to be all my possible y values. So my range, well, this is y, this is also y. So those are the full quantities there. So the range are all the possible outputs we could get. We have to think logically with the numbers that I'm plugging in, what kind of answers could I get? So for example, in this set, we can show the set by using these fancy little curly brackets. The domain is going to be all of my x values. So I have 1, I have 3, I have 5. So my domain, appropriately enough, is 1, 3, 5. And my range is going to be my y values. So 2, 4, 6. That's exactly what my range is. So it's really just the range is identifying your y's. Domain is identifying your x's. The way that I remember this, which it might not work for everyone, but this is my way, is that if I go in alphabetical order, domain D comes before R, and X comes before Y. So I just kind of pair them off with these two come first alphabetically, these two come second alphabetically. But you can obviously come up with your own way. All right, so pause this video for like a minute and try to do this bottom part if you haven't already. So try to identify the domain and range of the following. Okay, so you should have done these problems already. Let's check your answers. So the domain and range of the following. This first one, my domain. Oh, that one's hard to write. Let's try cursive. Ooh, A-I-N. My domain are just my x values. So 0 is an x value, 8 is an x value, 9 is an x value. I'm going to use my little curly brackets to show that it's a set of numbers that I'm referring to. So it's 0, 8, and 9. And again, my range is going to work really similarly, just now I'm taking the y values. So I'm looking at my y values. I see 4, 7, and 0. So that's my range. So 4, 7, 0. Okay, I'll move on to this guy next. So my domain, again, I'm just going to take my x values, and they're so nicely labeled for me over here. Wonder if I can just... So my domain for this one, I don't know if I can move this, but I'm going to use my nice curly... Oh, man. Okay, I'm going to use my nice curly brackets. And I have 7, 4, 3, and 9. You don't have to put them in increasing numerical order. It's probably nicer if you do, but that's fine. It's expressing the same information. And then my range, it's going to be all my y values over here. So I see 1. Well, I already said 1, so I don't need to say it again. 2, and 3. I'd like to stress that even though the output of 1 repeats, this is still a function because each input, each of my values in my range, goes to its own one unique y value. So 7 doesn't go to 7 and 2. 4 doesn't match up with 4 and also 3. Or 1 and 3. All right. Let's take a look at this last one. So my domain, I'm going to be looking at all of my x values here. So x is -3, x is -2, x is 0 here. Sorry, I have to continue down like this. X is 1, and x is 2. Ideally, you don't really want to drop these down like this, but it's going to have to work for right now for me. Oh, wait, maybe I can move this. Ooh, there we go. Okay. All right, and for my range, I'm just going to go to those x values and look at their corresponding y values. So when x is -3, y is 2. Oop. When x is -2, y is 0. When x is 0, y is 3. 1 and 0. Oh, but I already used 0. I did not need to write it twice. And then when x is 2, y is 4. All right. So again, in identifying my domain and range, domain, I'm just going to pick and choose all of my x values. Range, I'm just going to pick and list all of my y values. Nothing too crazy. All right. So when you're given a problem about domain and range on the regions, More often than not, it's going to want you to identify an appropriate domain or an appropriate range given a word problem. Now, in our warm-up, we kind of did this. We listed examples of numbers that would be reasonable. But for the regions, they're not just going to want examples of numbers. They're going to want the type of numbers that they are. So we need to know our number systems. The nice thing is, these number systems kind of formed in a logical way. So for the first kind, I think of, when you're teaching a baby how to count for the first time. Or if you think way back, I think of those cavemen like walking around arguing over whose rock is whose. And they're saying, oh, I have 2 rock. No, give me 3 rock. So these are our natural numbers. The ones that kind of popped up naturally that you really needed to just have a concept of counting. And those are going to be numbers like 1, 2, 3, 4, 5, 6, 7, and so on and so on. That's going to include 9,438. It's going to include 1,000,002. Just any numbers where you keep counting up by 1. So start at 1, count up by 1s. So you could just keep adding 1 on. All right. So after the natural numbers, oh, I want the blue. Okay. We might have gotten another caveman who was feeling kind of sad because he didn't have any rocks, but he had no way of expressing that idea. He had 0 rocks. So our next number system is literally just a way of adding in the concept of having nothing. So now we have the whole numbers, which are going to include every single one of the natural numbers. So 1, 2, 3, 4, 9,438, 1,000,002. And literally the only number it adds in is 0. All right. So we'd have 0, 1, 2, 3, 4, 439, 9,235. The key with the whole numbers is just that 0 is added in now. So there we go. And I kind of like to remember that one because 0, if you stretch your imagination, kind of looks like a hole. So falling into the hole. So the whole numbers just add 0 in. So if the Regents is asking you about something like how many pets someone has, whole numbers would be appropriate because someone could have 0 pets. All right. So now we can count, up by 1s forever. We have an idea of having nothing. But what if we have less than nothing? That's where our integers are going to come in. So if you're in debt, if you are below sea level, we needed a way to express that. So maybe we have things like -5, -4, -3. I mean, we still have 0. We still have 1, 2, 3. And just anything continuing on in either direction from here. So we could have -947. We could have +423. The integers are just where we add in negatives. All right. And, I took a history and math class a while back, and I'm fairly confident, I should really fact check this. I'll fact check it and put it in the captions if I'm wrong. But people were arguing over whether or not negative numbers should exist up until like the mid-1800s, which is a wild concept to me because these numbers popped up in the BCs and negatives took that long to really gain momentum. I mean, I think they were around earlier, but there were still people who were like, no, 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 we can't have those. But again, I'll fact check myself and toss a comment in if I'm wrong. I don't feel like looking it up at this second, though, because getting this program going is a pain. All right. So now we have integers, which just gave us negative numbers. Our final number system on this little piece here, we're going to have rational numbers. So rational numbers, so we have our counting numbers, we have 0, we have negatives. Now we need fractions and decimals. So like if you have, well, I mean 3 works, that's like 3.0, 4, 5, 6, all of those counting up. 0 is still in here. -4, -3, -2, all still in here. And now I get like 9.25 or 3.12 or 6.84. I can also do it as a fraction. So we're gonna have something like 1/2, or even kind of a not so nice fraction, like 907 30-seconds. That's fine. With rational numbers, you're going to be able to tell it's rational because the decimal will repeat or terminate if you write it in decimal form. Okay, I'm going to make this a little more precise. Number which can be written as a fraction. Its decimal will repeat or terminate, and I'll show you what that means a little bit. All right. So something like 0.12121212. The dots are showing me that it continues on forever, but it's repeating, so this guy would be rational. It would actually be 12/99, in fact, because it can be written as a fraction. Or a decimal like 98.234. I'm just pounding on the keyboard. Whatever I got there, it terminates, so it's going to be rational. All right. We're going to go into rational and irrational numbers a little bit more later on down the road, talking about square roots, but I just want you to be familiar with this for now. Okay. If I actually just said the other kind, if these are rational, so all of these numbers are rational, the integers, the whole, the natural. The other kind of number that we have are irrational numbers. And if rational numbers, their whole definition is that they can be written as a fraction and their decimal repeats or terminates. Irrational numbers cannot be written as a fraction, as a decimal. It doesn't repeat the same pattern or end. So something like, I don't know how to type pi on this right now, but pi. So like 3.1415. I think it's like 842 maybe. I don't know though. I haven't memorized pi. I haven't reached that point in my math life yet. So that would be irrational because it keeps going on forever and ever. There's still a computer somewhere calculating digits of pi, and it is not done. So it's going to keep going on forever. Something like 9 point. Again, I'm just going to slam on my keyboard and put a ... at the end. If it keeps going on and on with that nonsense, that's going to be irrational. Something like 0.01001000100001. And it repeats, or sorry, it doesn't repeat, it continues with these dots. This guy's going to be irrational because even though logically you can tell what's coming next, I'm not repeating the exact same pattern. So I can't draw a bar over this to express it. So I have like the 0, 1, Why is it not? Okay. 0, 0, 1, 0, 0, 0. It's not the exact same string of numbers. All right. So make sure you copy this little diagram down. I know mine's a little bit messy, but the important things to know are being able to recognize these different kinds of numbers. We'll go into recognizing rational and irrational more in a little while, but just so you are at least familiar with it. All right, now I'm going to leave you with a wonderful video to kind of review these. My offer will perpetually stand that if anyone wants to help me re-record this video, if anyone can carry a tune and help me out, there is extra credit on the line. So if you are desperate for extra credit and you can carry a tune, please, please, please come in and see me when I'm back. All right. All right, and I want you guys to just hit stop on your video here. Splicing them into multiple videos like I did for the last one was a pain because they took forever to upload. So again, splice it here. Just hit stop, go on to your next slide. Stop. All right. So as that wonderful little video showed you, all of these numbers that I'm dealing with here in this giant box are going to be members of my real number system. Every number that you guys are going to see this year is going to be in the real number system. You're not going to be dealing with the other kinds of numbers, which are actually called imaginary numbers. You're going to be seeing those in future math classes. If you want to chat about them, I'm more than happy to do so, but you don't have to know it for this year. All right, let's take a look at another kind of problem, though. Or I guess, yeah, the kind of problem you're most likely going to be seeing on the Regents. So, a salesman is selling cars. The function S of C represents the amount of commission he would make after selling C cars. An appropriate domain for this function would be either the real numbers, the integers, the whole numbers, or natural numbers. All right. When I'm looking at this problem, my first thing that I'm thinking is I want to know, what am I looking for? I'm looking for an appropriate domain. Well, domain corresponds to my x values. So I'm looking for x values for this function. Well, let's see what the context of my x values are. Well, the function S of C. I know that notation, like an f of x, a g of x, an S of C, is my fancy way of representing y. So these are just my y values. And it represents the amount of commission he would make after selling C cars. Well, C is what's being plugged in here. That's in my X spot. So I'm looking for X cars. All right. Let's see which would be most appropriate. Real numbers are all of those numbers that we saw up there in that chart. So things like negative 3.72 or pi or 937 fourths. That is not an appropriate number for the number of cars. I cannot sell pi cars. So that one is out for me. All right. Integers. This is where my negative numbers come in. Can I sell negative 4 cars? I cannot unless, no, not even if I'm truly terrible. Unless people start returning their cars to me. But I don't think that's what's going to happen. So integers are out because you can't sell negative cars. Whole numbers, all right. So that would be like 0, 1, 2, 3. All right. Well, that seems pretty reasonable. So I'm going to leave that one in for right now. I want to see if anything is better. The natural numbers are like 1, 2, 3. So the only difference between these two is the addition of 0. And I do think it's appropriate that he could not sell any cars. So I'm going to choose for my domain whole numbers. Okay. Now we're looking for an appropriate range. Now range, I remember, goes with my y values. And looking up here, my y values represented the amount of commission he makes. Commission is a way of saying how much money he brings in. So I'm looking for numbers that would be appropriate for money made. All right. So which would be possible to be how much money he makes? Integers are like -3, 0, 4. Yeah, he could make those amounts of money. He could just make those, but more often than not, money is going to have change with it. So I'm going to get rid of integers. And in a similar light, because the whole numbers are part of the integers, I think these guys are gone as well. He's not, more likely than not, he's not going to make $10,032 on the dot. All right, so now I'm between rational numbers and non-negative rational numbers. Even if I don't know what the rational numbers are, which I do, those are like my decimals. Now I'm going to have things like 3.41, or for a car, $19,732.18. That seems appropriate. And I'm going to err on the side of non-negative rational numbers because you can't really make negative money. So non-negative rational numbers would be my most appropriate range. Okay, I'm going to have a short quizzes for you guys to do now. So look at your next page on that Unio and go to the quizzes so I can make sure that you guys know what domain, range are, and all these number systems.